The Cortisol Problem, Part 1, Stress and Genes. Every day, we are all subjected to stress, and if we don't learn to handle it, we can quickly reach a point of general discomfort and burnout. It is common knowledge that stress weakens the body and puts you at risk for certain diseases. There are several different kinds of stress, and each one has a different degree of difficulty in coping with it. Surely, everyone responds differently to the various stressors in our daily lives, but the end result is the same for everyone: nervousness, anxiety, and overall discomfort. All of these things contribute to worsen social dynamics/soft skills, and lower working efficiency. Let's look at the most critical aspects of stress, how it functions, why it puts our well-being at risk in some situations, and what genes are linked to stress. What is stress? Any change that induces physical, mental, or physiological tension is generally referred to as stress. When the present situation exceeds our ability to handle it, we become stressed. Now, stress is often perceived to be that everyday tension we all feel, but the thing is, this type of stress can actually be categorized as constructive stress. As a matter of fact, we need stress in order to perform at our best, but the issue arises when the stress becomes excessive. This may be the product of a heavy emotional load, a significant loss, or a series of mild, consecutive headaches that we are unable to recover from because they occur much too often. When we reach our physiological optimum, optimal stress leads to optimal efficiency. After that, the stress grows, and our efficiency decreases proportionally. The worst thing about this is that we can consciously intensify the stress levels, and most people actually do that. For instance, this can happen if we invest our negative thoughts and worries in the stress factors. I'm not good enough, I look silly doing this and that, or this is not going to end up well for me are common thoughts. The psychological mechanisms that occur inside of us begin to work against us, and we begin to experience the well-known stress symptoms as an end result. However, this is just one part of the picture, as there are other factors, such as genetics. The genetic response. Before we talk about ways to deal with stress and anxiety, it is important to point out that perception and tolerance to stress are also linked to your genes. The catechol-O-methyltransferase gene, or COMT for short, is one of the genetic factors that influences stress tolerance. This enzyme is in charge of degrading catecholamines including dopamine, epinephrine, and norepinephrine, which is quite a difficult job. Dopamine is a neurotransmitter that carries various signals between nerve cells, and it plays a role in the transmission of pain/stress signals across the body. So, effectively, this enzyme may be one of the determining factors of how we perceive pain and stress. Too much or too little dopamine can impair cognitive function, so we need to find that sweet spot. Dopamine levels increase when we are stressed, as we all know. Because of this, if you generate more dopamine, you can perform poorly under stress. Of course, if you generate less dopamine, you would do better since your dopamine levels are close to optimal, but then again, too little wouldn't be good either. When it comes to COMT, gender is just another deciding factor. Now, this is mainly because estrogen suppresses the COMT enzyme, meaning that the activity of this enzyme in the prefrontal cortex in females is significantly lower than in males. What this means is that females, by default, are closer to optimal dopamine levels, as opposed to males. So, while there are many variables that affect our ability to cope with pain and stress, at the end of the day, it's all about how you respond to your perception of stress, which will determine your outcome. Does this then mean that the stress response is not all automatic and can be controlled and regulated? Like the video, share with a friend and subscribe to the channel. Leave a comment below.